Hi there. Thank you for coming to our virtual talk for our paper, Making the Unaccountable Internet, the Changing Meaning of Accounting in the Early ARPANET. There's been a recent revival of interest in studying accountability in technical systems, particularly those that involve AI or machine learning. This work, much of which has been published at FACT, has drawn on various definitions of accountability. For example, Mark Bovins' work on relational accountability from political theory. Much of the work that draws on this has focused almost exclusively on accountability in relation to algorithms. The emphasis on algorithms has left broader systems and institutions in which algorithms are situated unattended in terms of their relationship to accountability. In our paper, we complement this prior work, taking a historical approach and examining accountability as it pertains to a specific computer system, the early internet and its predecessor, the ARPANET, situated in a time and a place, including its architectural components, protocols, and institutional actors. Unlike prior work, we don't take a top-down approach in which we posit our own definition of accountability. Instead, we investigate how an understanding of accountability or unaccountability can emerge and evolve over time during a system's development. Today, the internet is often described as lacking endemic features for accountability, fixing the perception that it is an unaccountable system. The history behind this predates current conversations on internet governance, dating to early papers on the ARPANET's architecture. One of the key players in these conversations was the guiding design principle of end-to-end. In the early 1980s, three members of the ARPANET project formalized the end-to-end principle, arguing that a communication network should implement most complex functions at the endpoints, rather than within the network itself, leaving the network's design relatively simple and focused on routing data traffic. In other words, things like accounting were not considered an in-network concern. Through various retellings of the internet origin myth, end-to-end became its defining feature, used to explain the network's exponential growth and celebrated for its architectural simplicity and even its political commitment to decentralization, individual autonomy, and freedom. The ubiquity of end-to-end discussions of the internet, from institutional histories to cyber law, has made it a stand-in for the internet as a whole. Tarleton Gillespie has noted that such a cultural uptake of one specific term has both obfuscated its contentious meaning and created a sense in which the architecture of the internet became a fixed material object. Among the many possible narratives that get lost in this end-to-end telling is the story of a difficult administrative, technical, economic, and political problem at the heart of the ARPANET, distributed accounting. This is where our work comes in. We survey the early years of the ARPANET project, which Susan Brahman has called the framing years, and go through the transition of the ARPANET to the internet. Our main focus is primary sources drawn from a subset of the Internet Requests for Comments, or RFCs. The RFCs are a chronologically ordered series of documents posted publicly and hosted online by the Internet Society. They represent multiple histories and can be read for their technical content, a community's self-reflection on its own history, and as source materials for analysts of governance formation. We looked at about 150 RFCs to get a sense of the evolving dialogue around accounting and accountability during the early 70s through the late 80s, to see how a hard to pin down concept like accountability gets concretely negotiated and defined over time, and how it is implemented or left unimplemented in complex technical systems. By our accounting moved through being understood as billing, as measurement, as management, and as policy. We organized the paper around these four notions with some nonlinear overlapping chronological progression. We trace how the historical actors designing the technical system that is the internet routinely debated, deferred, and discounted accounting as a feature of the network. And we see how, over time, this community came to define the meaning of accounting as constitutive of accountability. In tracing the shifting meaning of accounting in the first 2 decades of network computing, we offer retelling of internet histories, locating the unresolved problem of accounting as the obverse of the end-to-end elegant architecture solution story. In this talk, I'll focus on an example for the section on billing, a dialogue between 2 RFCs that capture the so-called story of so-called free file transfer. File transfer, implemented as the FTP protocol, has been one of the very basic functions of resource sharing since the very early days of the internet. It enables transferring files from one node to another, and its intended use was for researchers in the ARPANET to be able to share files with each other. This resource sharing, however, presented novel problems. Users wanted access to functions and files over nodes, but they also wanted priority over their own local computing resources. This motivated billing on the network. Remote users could be billed for usage to hopefully incentivize remote users to not overuse others' local resources. In tension with this, even if local users wanted remote ones to pay, they themselves didn't want to pay when they were in the role of remotely accessing files from other sites. And it turns out FTP had a loophole to avoid payment. It had a feature called mail file, in which one could instead mail themselves the file they wanted without actually ever logging onto the remote node. And without logging in, there would be no accounting of who that user was, and thus no way to track who to send the bill to. This became a very popular hack, and it effectively defeated the whole point of trying to set up accounting procedures to bill for resource usage. In response, an engineer named Ressler wrote RFC 487 proposing free file transfer, where free is used to mean loginless. He argues that there should be some cases in which file transfer is free, but instead of doing it in this hacky way with mail file, he suggests implementing an explicit feature to avoid login and thus accounting and billing. He argues that this will work as a solution because things like CPU utilization are negligible for file transfer, and so it would be fine to not be billed for those costs. But then another engineer, Ron, refutes this proposal in RFC 501. He critiques Ressler's, quote, sweeping assumptions about the nature and use of accounting mechanisms, saying that the things Ressler assumes to be free or of negligible cost are in fact quite costly, that nothing is free if you were the one who has to worry about cost. For example, while CPU utilization might be low for transferring one file, Ron contends this is not true for multiple files. Overall, the costs will add up and become significant, and they will need to be paid for. In short, so-called free file transfer would not actually be free. There are several takeaways from these two RFCs. First, accounting is hard. It's not the kind of thing that can be fixed by just adding an account field to the FTP protocol. Second, payment was clearly necessary. So-called free file transfer just punted the problem. Maybe at first that would be okay, but as the network was increasingly utilized and congested, it would not work forever. Eventually, someone would have to pay. Third, for labs to charge for the use of their resources represented a fundamental shift in the management paradigm of the ARPANET. Until now, ARPA had managed the overarching cost, but billing imposed a new burden of operational costs on individual sites, in which low-level bookkeeping was going to become crucial for the first time. In short, realizing ARPA's vision of resource sharing posed the need for accounting for resource usage. And accounting posed a non-trivial problem. And this was a problem that researchers neither knew how to solve nor really desired to spend time solving in place of performing their individual research. This was in part because of ideological reasons. Figuring out how to implement billing wasn't considered research. It was considered a secondary operational concern that was less important. And so accounting as a priority continued to get punted to later as something to worry about either when the network became saturated or when commercial actors took over and had to implement it so the network could remain financially viable. The RFCs also indicate that while accounting clearly involves billing, billing is not the only component of accounting. In the paper, we identify three other notions of accounting. The RFCs clarify the relationship between accounting for and measuring resource usage, a relationship that in fact very early on raised questions about the network's end-to-end architectural design. Our section on management explores how by the late 1980s, descriptions of what would constitute effective network management explicitly referred to accounting as a main component. These 1980s discussions prove that accounting raised serious questions about the boundaries of responsibility for and authority over elements of a network system. This was particularly the case as the system grew to be a network of networks, an early phrase to refer to the internet, in which the member networks potentially didn't trust each other or had competing interests. Lastly, we discuss how accounting eventually became identified with matters of policy, that in an environment of mistrust, accounting was clearly intimately related with issues like access control. At this point, when accounting was recognized as crucial for policy, it also became clear that accounting was essential for accountability. Beyond concerns of billing, accounting for resource usage was also about issues like who was using what, who was allowed to use what, and who or what type of traffic should get prioritized. Our work places accounting and its administrative associations squarely within the domain of both deep technical questions about the network and the political expectations of accountable technical systems. It shows that accountability is not a pre-given quality of the system that can be designed from the get-go, but rather is a set of emergent attributes that are negotiated throughout the design process, a process that itself is never fully settled in deployed systems like the internet. From this, we can see why technical systems that are now identified as unaccountable cannot be remedied simply by calls to implement greater accountability, which also run the risk of being mistakenly equated with a call to report everything as an audit best practice. Rather, taking stock of accountability as a result of complex negotiations in the ways that we do in our paper means first and foremost recognizing whose interests are accounted for in a given accountability regime. We close our paper by offering 3 broader takeaways, which together serve as a cautionary tale for the design of contemporary computer systems. First, the core design question in our paper is about resource sharing and allocation, a motivating problem in many computing applications today, especially in machine learning. The non-trivial questions involved in accounting for resource use in a distributed system are constitutive of the possibility of creating accountability. It's therefore worth interrogating how mechanisms for accounting may facilitate or obscure accountability. Second, we argued that developing accounting mechanisms was routinely deferred, not only because of the foundational tensions involved in developing accounting schemes, but because of a dynamic of discounting its significance. However, though dismissed as not a core research concern, accounting clearly was and is a fundamental challenge. Last, by taking an institutional approach to the history of technical objects, we argued that the broader context in which technological systems develop shapes the way accountability is defined and implemented, or ignored. Taking the administrative needs of this setting seriously would help clarify the necessary infrastructure to support concrete notions of accountability in complex technical systems. Even within the same technical system, the internet, our analysis shows how over time institutional changes led to shifts in understandings of accounting and the demands of accountability. Designing a definitive one-size-fits-all technical spec for accountability would therefore offer an abstract solution to a set of complex questions that ought to be addressed within specific institutional contexts. Thank you, and we look forward to your questions in the Q&A session.